Electrical components and symbols.
Design symbols of various control components. Circuit symbols are used in a circuit diagrams which show how circuit is connected together. The actual layout of the components is usually quite different from the circuit diagram. To build a circuit, you need different from the circuit diagram. To build a circuit, you need a different diagram showing the layout of the parts, clipboard or printed circuit board.
Wire and connection symbols. Wire connects components and passes current easily from one part of circuit to another. Wires join. A blob should be drawn where wire are connected but is sometimes omitted wire connected. At crossroads should be struggled slightly to form two junction as shown on the right. Wires not joining. In complex diagram, it is often necessary to draw wires crossing event two they are not connected. The simple crossing on the left is correct but may be misread as joint where the blob has been forgotten. The bridge symbol on the right leaves no doubt.
Power supply symbols. Cell supplies electrical energy. The larger line is positive. A single cell is often called a battery. But strictly speaking, a battery is two or more cells joined together. Battery supplies electrical energy. A battery is more than one cell. The larger line is positive. Solar cell converts light to electrical energy. The larger line is positive. DC supply supplies electrical energy. DC is in short direct current always flowing in the one direction.
AC supplies electrical energy. AC alternating current continually changing direction. Use a safety device which will blow melt if the current flowing through if exceeds a specific value. Transformer to coil of wire linked by an iron core. Transformers are used to step up, increase, and step down, decrease. AC voltage energy is transferred between the coil, the magnetic field, and the core. There is no electrical connection between the coil. Earth, ground. What? Earth, ground. A connection to earth. For some electric circuits, this symbol is used for the 0 volts of the power supply, but the mains electricity in some radio circuit, it really means the earth. It is also known as ground.
Output device symbols. Lamp, lightning. A transducer which converts electrical energy to light. This symbol is used for a lamp providing illumination, for example, a car headlamp or torch bulb. Lamp indicator. Transducer which converts electrical energy to light. This symbol is used for a lamp, which is an indicator, for example, a warning light or a car dashboard. Heater. A transducer which converts electrical energy to heat. Motor. A transducer converts electrical energy to kinetic energy, motion. Bell. A transducer which converts electrical energy to sound.
Buzzer, a transducer which converts electrical energy to sound. Inductor coil. Solenoid, a coil of wire which creates a magnetic field. When current passes through it, there may be an iron core inside the coil. It can be used as a transducer, converting electrical energy to mechanical energy by pulling on something magnetically. Switch symbol. Push to make switch. A push switch allow current to flow only when the button is pressed. This is this is the switch used to operate a doorbell. Push to break switch. This type of push switch is normally closed on it is open off only when the button is pressed.
Push to break switch. This type of push switch is normally closed on its open of only when the button is pressed. SPS on off switch. SPS ST, it means single pole, single throw, current flows only when the switch is in the close on position. Relay. An electrically operated switch, for example, a 9 volts battery circuit connected to the coil and switch. An AC means current the rectangle represent to the coil. NO, normally open. COM, common. NC, normally closed.
Resistor symbol. A resistor restricts the flow of charge. Use include limiting the current passing through outlet, and slowly charging a capacitor in a timing circuit. Some publication use the old resistor symbol. Capacitor symbol. Capacitors stores electric charge if can be used with the resistor in timing circuit for smoothing a supply and provide a it provides a reservoir of charge and can be used as a filter, blocking DC signals but passing AC signals. Unpolarized capacitor usually have a small value less the less than 1 microfarad. Diode symbols. Diodes, a device which allow current to flow in only one direction. Pasok.
Transistor symbols. Transistor NPN. A transistor amplifies current and can be used with other components to make an amplifier or switching circuit. This symbol is for a bipolar junction transistor. BGT, the type you are most likely to use at first. Transistor PNP, a transistor amplifies current and can be used with other components to make an amplifier or switch current. This symbol is for a bipolar junction transistor. BGT, the type you are most likely to use at first. Phototransistor, a light-sensitive transistor.
Audio and radio symbol. Microphone, a transducer which convert sound to electrical energy. Earphones, a transducer which convert electrical energy to sound. Loudspeaker, a transducer which convert electrical energy to sound.
Meters and oscilloscope. Voltmeter. Measure voltage. The proper name for voltage is potential difference, but voltage is more widely used. Ammeter. Measures current. A very sensitive meter used to measure tiny currents, usually 1 mA or less. Measure resistance. Most multimeters have an ohmmeter setting. An oscilloscope is used to display the shape of electrical signals. showing how they vary with time. It can be used to measure voltage at time periods.
Sensors input device LDR, a transducer which convert brightness, light to resistance and electrical property. LDR, light dependent resistor. Thermistor, a transducer which convert temperature, heat to resistance and electrical property.
Rotary switch actions. Controls in controllers are mechanical, electromechanical, or electro devices which use input signals to change conditions or values in processes or oversee access to buildings, gated areas, etc. Controllers generally receive voltage inputs from sources, analyze the inputs, and then oversee condition changes via signal outputs. Some controllers are simple manual devices for controlling airflow. For instance, controllers are handled in the family motors, controllers, and drives.
Types of control device and controllers device. Access control systems. Access control systems are electromechanical devices or systems composed of remote stations and centralized controlling stations which are used for controllers are sometimes called batch controllers for their ability to accurately control different ingredients in chemical batching process, for instance.
Pressure controllers. Pressure controllers are electromechanical devices used for controlling process, system, pressure in various industrial processes. Case specification include the intended application, type, control method, sensing element, and the pressure range. Pressure controller types include differential gap, proportional, on or off types, among others. They rely on a variety of sensing elements such as diaphragms, capsules, Bourdon tubes, etc. In operation, the controller receives a process or system pressure input, compares it to the desired set point of the pressure controller, then outputs a signal, usual to control or usual to a control valve, which adjusts the process system's pressure if necessary back to the set point. Controls in controllers range from relatively simple pump controls for level applications to sophisticated PLCs with multiple input or output from function and network communications used for full factory automation. Some flow controls for pneumatic systems are nothing more than manually adjustable valves that vary the air flowing in pneumatic systems.
Considerations. Controllers are often identified as single or multi-loop, referring to the number of inputs and outputs. Multi-loop controllers can receive data from more than one sensor and can output control functions to more than one device. Controllers are often mounted in enclosure and control panels with display and selector functions, available at the front of the enclosure and panel doors. Both LED and LCD readouts are typically available. Some PLC designs house the main controller behind the panel door and use door-mounted devices for displaying status and for selecting various control functions.
Input types will vary by controller, with thermocouple and RTD being common. Input types Input types
Input types will vary the controller, the thermocouple and RTD being common for temperature controllers. Output types. Output types again depend on the controller type, with many using 4/20 mA current, loops, or relay.
Next circuits.
What is a protection device? The circuit protection device is an electrical device used for preventing an unnecessary amount of current, otherwise a short circuit. To ensure the highest security, there are many protection devices available in the market, which offers you a total range protection devices for circuits such as fuse, circuit breakers, RCCB, gas discharges tubes, thyristors, and more. There are different types of protection devices. The different types of circuit protection devices examples include the following: fuse, circuit breaker, pulley switch, RCCB, metal oxide varistor, inrush current limiter, lighting assistor, spark gap, gas discharge tube.
Current limiting resistor. Current limiting resistor is a resistor that is used to reduce the current in a circuit. You would usually want to have a current limiting resistor in a series with your lead so that you can control the amount of current through the lead. If too much current is going through your lead, it will burn out too fast. If too little current is going through it, it might not be enough to lit the lead. Calculating the necessary resistor value. Check the data sheet of your component to find voltage drop and the appropriate current for your lead. If you cannot find a data sheet, you can test it. Connect the lead and the resistor in series to a variable voltage source. Start at 0 volts and increase the voltage gradually until the lead is up. Measure the voltage over the lead and the current going through. Let's say the lead needs 15 mA and has a voltage drop of 2 volts. You have a 5 volts power source that you would like to power it with Which resistor's value do you need? To find the resistor value, we start with finding the voltage drop over the resistor. Since there is a 2-volt drop over the lead, there will be a 3-volt drop over the resistor. Okay, so we have 3 volt and we want to have 15 mA going through the resistor and the lead. Equations. Utilizing the basic principle of Ohm's law provides this formula. Resistor equals supply voltage minus lead voltage drop underscore numbers of leads in a series over